All right. Good evening, everybody. I want to say it's an opportunity to be here, and I hope that while we're here, I'll be able to pass across whatever message I'm supposed to be passing across. At the same time, I hope that we can all hear me while the class is going on. If there's at any point we can't hear, please, I would like that somebody humbly let us know. So, my name is Bumi Balogun. I happen to be an AI engineer for Innovate Solutions. Innovate Solutions is a software company at the heart of Lekki in Lagos. And I happen to be an AI engineer for Innovate Solutions. On a day-to-day basis, we deal with a lot of data and a lot of model building because of the kind of work we're doing every day. It requires that we build a lot of machine learning models, which is why I'm here today. From the curriculum that was sent to me, we're going to be talking about the types of machine learning algorithms. We're going to be talking about the types of machine learning algorithms. And so far, I've been, in the little way I can, I've been following some of the curriculums that we've been doing. And I must say that so far the team has been doing its best to make sure it delivers output, the optimum output for everybody. And I'm hoping that we're all following the class from the very beginning, because it's only when we are doing that that we'll be able to understand this whole concept of machine learning. That is after we've gone through the introduction to Python, after we've gone through NumPy and Pandas and all of that. It's only at that point we can begin to say, let's go into the concept of machine learning. So like I said, today, what I'm doing today is to go through machine learning for us to see how we can understand the concept. It's just the basic introductions of machine learning. All right, so I'm going to share my screen for us to see the notes. I'm hoping that I can do that. Okay, the host disabled participant from sharing screen. All right, so I'm not allowed to share. All right, so I'll go straight into why we're here and explain in the very little way that I can. And I hope that I'm going to be getting some form of feedback so that I will know that I'm not just talking and talking and nobody's hearing me. So what is machine learning? That is the first thing we're going to be asking ourselves. What is machine learning? What is machine learning? The basic understanding of machine learning is simply the process of making a machine learn the patterns that exist in data and to produce inference based on the learned patterns. I'm going to take that again. Machine learning is simply the process of making a machine learn the pattern that exists in data and produce inference based on these patterns. So from this definition, there are two things we are going to take note of. First of all, is the fact that you're making machines learn pattern from existing data, right? So which means first things first, it is very important before a machine learning model can be built or before a machine learning system works, there have to be data in the first place. There has to be data. Without data, then you can't build those models you intend to build. Now, at the point where you've understood, or at the point where you've had your data, that is when you then look into learning patterns from that data. Learning patterns from that data. And I'm going to give a simple example of what we mean when we say we're trying to learn patterns from the data. You find out on a daily basis, most of us humans, we're stuck with a regular kind of pattern that we might not even be aware of. Our day-to-day life activity is the same thing. So an average human being wakes up in the morning. Let's say all of this was before the COVID-19 situation, right? An average human wakes up in the morning. A couple of us that are religious have our prayers. The next thing we are going to bathe. And after bathing, some of us have the opportunities to eat. And after eating, we're dressed up and we've gone to the office. Now, most of us work in an average Nigerian company that requires you work from 8 or 9 o'clock till 5, right? And then a couple of times we are doing the same set of tasks in the office every day. Only a few days will you notice that those tasks change. Other times we're repeating the same set of tasks every day. Now, from that 8 to 5, immediately work closes, we're going back home. By the time we get back home, we carry out a few activities and eat and all that, and then we call it for the day. Now, we might not notice, but we're having repeated patterns even as human beings every day. Now, one of my mentors will say, everybody is a data point in somebody's database. Everybody is a data point in somebody's database. Which means one way or the other, there's something you're doing that is being captured by a particular system. There's something you're doing that is being captured by a particular system. Now, the same thing works for machine learning. We've understood that there are certain things that machine learning requires. We've understood that there are certain things machine learning requires. Like I said, machine learning is simply the process of making a machine learn the pattern that exists in a data, and then to produce inference based on the learned patterns. We have a data that has been given by the system. We have a data that has been given to the system. The next thing is we'll look into having that data. The next thing we look into is to making sure that that data there are certain patterns that the machine will learn from that data. So just like the human being scenario, the machine will learn existing patterns in that data. Now from that data, it can then produce inference. Now, what do we mean by that? Because of the fact that I know Mr. A is somebody that is repeating the same task every day. He goes to the office, he comes back, all of that on a daily basis. I can then predict or bring out a report that in the next 1 week, Mr. A will wake up from his bed by 7 o'clock. He will have his bath, pray, eat, and go to work. He will get to work by 7:45 and then work till 5 o'clock, and he will leave the office. He will get back home by 6 p.m. and so on and so forth. Now, I've been able to produce inference based on the fact that I've learned Mr. A's pattern. And that's the same thing with machine and algorithms, right? It follows patterns. Now, there are 3 categories of machine learning algorithms, 3 very important categories of machine learning algorithms. And I'm sure a lot of us have heard this over time, over and over and over. We're going to just explain it in a more granular term today. Now, we have what we call supervised machine learning. We have what we call unsupervised machine learning. And we have what we call reinforcement machine learning. Supervised learning, unsupervised learning, reinforcement learning. These are the 3 categories of machine learning algorithms. all forms of algorithms, all forms of data, all forms of model building, one way or the other, must fall into these categories. However, there are some cases where during my time while working around data, I've seen some cases where most organizations go as far as saying there's something called the semi-supervised, right? But I'm usually of the idea that there's nothing as semi. It's either it's supervised or it's not supervised, right? So all algorithms must fall under this category when it comes to machine learning. Supervised learning, the unsupervised learning, and the reinforcement learning. Now, what is supervised learning? Simple. Supervised learning is best taught as learning the pattern in a data set that has a mapping to some specified outputs. Learning the patterns in a data set that has mappings to some specified output. So there's something I want us to take note of here that is very important in supervised learning. It says specified output. Specified output. Now we have an example here, right? The example is a data set that consists of columns of temperature, rows and columns of temperature, humidity. Temperature and humidity. Now, it takes temperature and humidity as the data set we are going to be learning. And then it takes the column rain or no rain as the supervisor. What do I mean? In supervised learning, you already have your outputs given to you. So somebody comes and tells you, I have this data set that I've been able to web scrape, or I have this data set that I've been able to pull out from a database, right? And I also have the output from this data set. What I want you to do is find patterns for me from my data set and map those patterns, relate those patterns to the output that I've given you. Now, a simple example is in the e-commerce space, in the e-commerce business. Somebody comes up to you as a data scientist in an e-commerce company and he says, I have a data set of my customers for the past 6 months. And this data set contains a lot of columns and a lot of rows. But everybody bought a particular item at a particular price. So my output is the price. Now I want you to relate customer spending habits, customers' observations, customers' decision making, and map it to the output. Now, possibly what you can find out from there is a data scientist can look through that data and tell you as the owner of the business that he noticed most of your customers bought, most of your customers went to buy foodstuffs more. You have more people buying foodstuffs in your shop. You have more people buying electronics in your shop. You have more people buying food items in your shop, right? Now, you've specified the output for this person. The data output has been given to you. All you're just trying to do is to use the data that is provided, learn patterns from that data and map it to the output. Learn patterns from that data and map it to the output, right? So there are many cases where you use supervised learning. A lot of the industry cases where you use supervised learning. Mention of the e-commerce space, even in the energy sector. There's a data set I'm currently working on. It's a data set from the energy sector. And they're trying to relate a lot of data to the price of energy over a particular period of time. So in that case, they've already given me my output data, which is energy quantity, energy price. And then I'm supposed to find patterns from all of that data sets to the energy price. Now, the way this works is you have your rows and columns that are called your input data. Your rows and your columns that are called your input data. And then you have your output data. So in the example we have here, temperature and humidity, they are our input data. And then the supervisor, which is the rain or no rain, is our output data. So simple quadratic equation, you have y is equal to mx plus c. where y is a dependent variable and x is the independent variable. So in this case, temperature and humidity are all the values of x, while your y is the supervisor, which is your specified output. Now, we were able to split this data into two different iterations. Right? We were able to split this data into two different iterations, and we had our observation. For the first iteration, we decided to split into rain or no rain, rain or no rain. Now we collected the first data set, the first row, 25 and 50 for temperature and humidity. And then the next row, 33 and 78 for temperature and humidity. And then we classified it under rain. Then we went to the third one, temperature and humidity, 30 and 74. And then the last one, 27 and 63. And we classified it under no rain. Now you find out that classification clearly has stated that the first one is wrong. It is not correct because our output has already specified that first row, row 0, as a row with no rain. But here we've classified it under the classification of rain. Therefore, it's an incorrect classification. You can also see as well the second column, that's third column, number 2, has 30 and 74 as its variable, as its figure values under temperature and humidity. And then we've classified it under no rain. Unfortunately, we already have the fact that our output has specified that that particular row has an output of rain. Therefore, that is a wrong classification. So we decided to do a second one. And in this case, we've clearly classified our data into rain and no rain data, therefore having a correct classification. So you can see the essence of having your output. Your output variable has already specified ahead of time. Before you make these classifications, your output variable has already told you which row has your rain and which row has no rain, therefore helping you in knowing how to classify your data set. This is what is called supervised learning. Now, under supervised learning, there are a lot of algorithms that people use in supervised learning. There are a lot of algorithms people use in supervised learning. But the two basic algorithms are classification and regression. Classification and regression. Now, classification is just a simple example of classification is what we did in the first place. This one, where we classified our data set into rain and no rain. Where we classified our data set into rain and no rain. That is a simple example of classification under supervised learning. The next one is regression. The next model is regression. Now, regression is basically another popular platform that works for supervised learning models. And usually, there is usually a model that fits into statistical data. Statistical data. What do I mean by that? For example, the area of the guys working with price in an e-commerce platform. The guys working with price in an e-commerce platform. If your output data is a list of prices, you find out that the best method to use is regression, because if you have too many lists of prices, you cannot start classifying your data set into different prices, right? Classification models best work when you have two major sets of outputs. Like this first example, we have the rain and we have the no rain. We have the rain and the no rain, two various outputs. Therefore, we can classify our data into those two outputs. But for regression, regression basically works with numerical values, numerical data, data where the output is not classifiable. Like I said, the e-commerce example, let's say you have prices of various items on your store as your output data. it will be very difficult for you to start classifying price of biscuits, this, price of this, into different classes. Instead, you're going to be using the regression algorithm to fit into classification data. That is the difference between classification algorithm and regression algorithm. Remember, all algorithms are under supervised learning. All algorithms are under supervised learning. Simple. Regression algorithm helps you predict output values based on these input features. And most times, they are usually best used for numerical data sets, numerical output values. Now, the other ones here are KNN. That is the K nearest neighbor. Now, the KNN is, I usually consider it another example of classification, because what it means is you're going to be relating items based on their nearestness, how near a particular item is to another. So we have a graph here that shows green balls and red triangles. And then we decided to pick from this data set. We found out that two of our green balls at one side are close to one of the red triangles, right? That's what K nearest neighbor is all about. K nearest neighbor is all about classifying data sets based on the nearest neighbor, which particular data set is closer to which particular data set. How close is data set A to data set B? By the time you measure their closeness, you then classify it into a particular, you then classify it into, you then use your K nearest model, your K nearest neighbor model, and classify those data sets. Now that is another example of another family under supervised learning. Now you also have the guys like support vector machine, but today it's my duty to introduce us into all of these families and all of these algorithms. Now, we also have, remember I talked about linear regression, I talked about regression earlier on as a family of supervised learning, right? Now we have what we call logistic regression and linear regression. We have what we call logistic regression and linear regression. So I'm going to do a little bit of explanation between the difference. Now, logistic regression is usually used when the dependent variable, that is your output variable, is binary in nature. Now, what do I mean by that? When your output variable is simply yes or no, that's the basic logistic regression model. When your output variable is simply yes or no. So a simple example will be, if you have a data set of workers in a particular company, and from your data set, you're being asked the information if a particular worker has resigned or has not resigned. So the output variable for worker A will either be yes or no. The output variable for worker B will either be yes or no. The output variable for worker C will either be yes or no. So you know that there are two basic output variables. It's either it's yes or no. Now in that case, logistic regression comes into your model. Linear regression is used when the output variable is continuous. When the output variable is continuous in nature. So simple. Numerical values. Like I simply explained earlier when I was talking about regression. Numerical values. That's a simple example of using linear regression. Now, also here we explain the concept of decision tree. Decision tree is simply putting together a tree-like model So we have a simple example where you've been asked if the temperature is greater than 27. Now, if you say no, it means there is no rain. Now, if you say yes, the next question will be, based on the temperature being greater than 27, is the humidity also greater than 69? If you say no, it means no rain. If you say yes, it means there's rain, right? So this is a decision tree model. You have your data set with your output variable. In this decision tree, they pick the first one. You have your data set with your output variable, and then you pick each component from your output variable and form a decision tree-like model. Therefore, categorizing based on that feature, is it a yes or a no? So we've picked the temperature feature, and we've asked, is the temperature greater than 27? And the answer is no. And then we come back. If it says no, it means no rain. And then we ask, is the temperature greater than 27? If it says yes, then we'll go further and ask again, is the humidity greater than 69? If it says no, it means no rain. Is the humidity greater than 69? If it says no, yes, it means there's rain. So now I've been required that we'll take a break. We'll take a 5-minute break to reconnect back immediately after 5 minutes. And I hope that everybody has been following and we've understood the basic concept of machine learning and supervised learning. By the time we come back, we're going to be talking about unsupervised learning and reinforcement learning. Let's take a break and see you back in a few minutes. Thank you.
Thank you very much, Bumi. That was a very, very impressive presentation so far. So like you said, we'll reconnect back within 5 minutes. So by 5:35, we should be back. All right, so I'll end it right now. Okay, welcome back, everybody. Mr. Bumi, you have the floor.
All right. Thank you, everybody, and welcome back. I really hope the conversation so far has been interesting. We've been able to dissect the concept of supervised learning, which is one of the categories of machine learning. And now we are going into understanding what is unsupervised learning. Now, unsupervised learning is simply a method that tries to group a set of database exclusively on the patterns that exist in the data. It does not use any output to map out. Now, let me give us a simple scenario. When we were explaining this data set, temperature and humidity, we were able to separate the data set in the second iteration using our output variables of rain and no rain. So the data set will either fall into the category of rain or into the category of no rain. That was what we did under supervised learning. But in unsupervised learning, you have no output. Your system will be able to, the machine would be the one that will exclusively group the data set without mapping it based on any guide from the output. Now, a simple scenario is this. We have a data set of cats, bats, dog, vulture, goat, and eagle. But our machine was able to group it into two. Now, it grouped it into animals with 4 legs, and then birds. We have the cats, the dogs, and the goats with 4 legs, and then we have the bats, the doves, and the vultures and the eagles as birds. Now, this is a simple scenario of unsupervised learning. You do not have an output variable. Your machine would be the one to find hidden patterns in this data. Unsupervised learning requires in-depth of building algorithms that would go in-depth to find hidden patterns and hidden features that will relate variables to one another. Now, it's very possible that somebody can look at this data and group it into, a machine can look at this data and group it into something else. It's very possible. That's the funny thing with unsupervised learning. This particular machine now was able to group it into animals with 4 legs and birds. But it's very simple that you can find another machine that will group it into animals that can be birds and animals that can be domesticated and the ones that cannot be domesticated. It can tell you cat, dog, and simply doves can be domesticated. And then it will tell you bats, vultures, goats, and eagles cannot be domesticated. Right? So that's the beauty of unsupervised learning. There's no output variable. All it depends on is your algorithm, your machine learning model. It is based on your model, it will then group out your data set and give you an output. So you, as the machine learning engineer, will decide how you want to build your model for it to give you the desired output that you want. I gave a scenario of grouping this into domestic and non-domestic animals. Now, somebody that is building a machine learning model and wants to build it separate, give an output of domestic and non-domestic, would end up having you will have to build machine learning algorithms that will allow him to do that. You cannot build a machine learning algorithm that has one function and then gets a different kind of output. It doesn't work that way. The desired output that you want is totally dependent on the kind of algorithm you build when it comes to unsupervised learning. Now, just like the supervised learning, there are a couple of things that also exist in unsupervised learning. You have the k-means clustering, you have hierarchical clustering, and then you have the principal component analysis, spectral clustering, and a lot of others. There are a whole lot of other algorithms that are under unsupervised learning, right? But we'll go into explaining them one after the other. Now, the first one is talking about k-means clustering. Remember when we were talking about supervised learning, we talked about k-nearest neighbor. We talked about k-nearest neighbor. And now in unsupervised learning, we're talking about k-means clustering. Now, let me show you the difference. Now, k-nearest neighbor is under supervised classification, which we all know, and is a supervised machine learning algorithm. Whereas k-means clustering, as we all know, is also an unsupervised machine learning model. But the difference is, while they might seem similar, it feels like, yes, both are very dependent on clustering based on nearestness or based on the neighbors and all that. The difference is that for k-nearest neighbor to work, you need to label your data that you want to classify. For k-nearest neighbor to work, you need to label your data that you want to classify. Now, what do we mean by that? If you look at this case, we've clearly labeled our data. We have clear two sets of data. We have a triangle and a circle, right? We have the triangle and a circle. And these are labeled data that we want to classify into clusters, therefore using the nearest neighbor path. But for k-means clustering, our algorithm first sees every data point here as a circle, not minding the color. The first thing it does is that it sees every data point as a circle. Then the algorithm starts to separate it based on colors. It then starts to separate it based on colors. Remember I said unsupervised learning would look through your data points and find hidden features and then give you an output. Now that is what k-means clustering requires. It requires only a set of unlabeled points, and then you give it a threshold, and then it begins to pull out those points gradually based on features, based on fetching features, and then it clusters them into groups by giving the average distance between the points. So now it has clustered A and B, and we have an average distance between all points A and points B. First of all, the system will look through our data and found out hidden features in our data set. And the features were, some of the circles were green and some were blue. It then separated these features and then gave us an average distance between both labeled points, point A and point B. Whereas supervised model classifies based on circle and triangle and then find the nearest neighbor between both data points. What's the closest data between both features? We have the circle and the triangle, and we found out this is our nearest neighbor, K1. And then the other circle outside, the dotted circle, is our K2, which is our second nearest neighbor. This is the difference between KNN and k-means clusters. Now, the other one that we're talking about is hierarchical clusters. Hierarchical clusters. This is another example under unsupervised machine learning. Now, hierarchical clusters are simply clustering systems based on hierarchy. Now, we all understand the concept of hierarchy. Let's say in an average Nigerian home, growing up, we learned that the hierarchical structure is that the father comes before the mother, then before the child, right? Now let's take that ideology into machine learning, unsupervised learning. You're going to be separating data points based on hierarchy. You're going to be clustering data points based on hierarchy. Now, each data point will fall into the hierarchy that it fits into. Each data point is going to fall into the hierarchy that it fits into. Remember, for it to know which hierarchy it fits into, it has to be able to find hidden patterns in all of the data set, which once again draws us back to our definition of unsupervised learning. There is no output. There is no output. All you're given is your data point, and you're building an algorithm that would cluster through your data point and find relational databases, relational points that will cluster systems together. Relational points that will cluster systems together. And that is our basic understanding of unsupervised learning. Like I said, along the line, while we're going through this class, we're going to be seeing how these algorithms work. We're going to be working with data sets that would explain these algorithms. But today, my job is to explain the concept of machine learning. Now, the final one which we'll go through in this program is reinforcement learning. Reinforcement learning. Now, this is simply machines learning based on interactions from their environment. Machines learning based on interactions from their environment. Now, this form of machine learning learns based on two things: rewards and punishment mechanisms. Rewards and punishment mechanisms. So let me give a very basic example. Imagine This is usually an example I normally use when I want to explain this to very, very beginners in the field. Imagine in your house, you normally beat your child at exactly 3 p.m. every day. 3 p.m. every day, you get to flog your child. Now, fortunately for you, you have a robot that is in that house that notices that at 3 p.m. every day, you flog your child. And then after flogging, you flog your child either based on the punishment that the child has caused. However, if the child does something good, you don't flog the child. Instead, you reward the child with a biscuit. You reward the child with food. Now, your robot starts to learn these things. It starts to learn that when the child misbehaves, this parent comes back at 3 p.m. and flogs the child. When the child does not misbehave, this parents come back at 3 p.m. and reward the child. Now, bring that kind of ideology into the areas of machine. Machine reinforcement learning is going to be learning based on interactions with its environment. It is what it sees happening in the environment that it's going to use. Whatever it's noticing in the environment, it will use it. It works based on rewards and based on punishment. It takes suitable actions to maximize rewards in a particular situation. Now, one interesting thing about machine reinforcement learning is, even in the absence of a data set, even when there is no data set, reinforcement learning algorithm is bound to learn from its experience. Reinforcement learning algorithm is bound to learn from its experience. Even when there is no data set, it begins to pull data from its experience based on the environment. It begins to pull data from this experience based on the environment. The decision of this machine is totally dependent on what it's getting from the environment. So if you want to build a reinforcement learning algorithm, you have to be careful what you're exposing that software agent to. What are the kind of things it's going to be interacting in its environment? What are the things that you're exposing it to? Because it is from this point that it's going to be getting all of its data points, even when you have not provided data for it. Remember the quote I gave when we started this. I said, everybody is a data point at somebody's database. Everybody is a data point at somebody's database. So reinforcement learning seeks data points from actions in its environment. From actions in its environment. That is one of the third classification of machine learning. So today we've learned 3 different classes. We've learned the supervised learning, we've learned the unsupervised learning, and we've learned the reinforcement learning. All 3 algorithms are very important to know. There are some data scientists and machine learning engineers that you hear, they'll tell you they only want to learn how to build supervised learning models, and that's all. But it's not supposed to be that way. In real world cases, there are sometimes we would have to encounter unsupervised learning. What then happens to you that have decided not to learn this? And then even goes as far as in real world cases, you might encounter reinforcement learning. What have you built or what have you learned for you to be able to understand reinforcement learning? Nowadays, one of the major applications of reinforcement learning is usually in gaming systems, where we are playing against computer. A few games now are out there where computer begins to learn from its interaction with the human being in this game. And while human beings are interacting with it, the computer is learning and making itself better, to then get to the point where it will be very difficult for the human being to come in and beat the computer against itself. This is one very popular case in reinforcement learning. Reinforcement learning is quite interesting. It's still very, very huge, and a lot of people are still going into the space. when it comes to neurodynamic programming, approximate dynamic programming, all of this is reinforcement learning. And it's a very big space that a lot of people are still going into. So once again, I hope that we've been able to understand the basic concepts of machine learning. I hope we've been able to understand all three categories of machine learning. And as time goes on in the class, I'm very sure we'll be able to also learn how to work around these things when we're given data sets. I'm going to pass it now back to your teacher. Thank you everyone for listening.
Thank you very much, Mr. Bumi. I think your class was aptly delivered. I can't really point out any salient points that you missed out on. So thank you very much for your time. So I'm going to pass a short quiz to the class, and I still hope you hang around so you see the feedback from the quiz. All right, so I just sent it to the chat group. So don't worry, your names are not captured. It's just the questions there, and we can't really see who does what. It's just a self-assessment kind of quiz. So I implore everybody to attempt it. All right, so let's try to get it done within 5 minutes. And while we do it, let's also prepare questions for the facilitator of the day. So if we have some gray areas, let's ask. So let's get this done by 6 o'clock. Then ask questions for the next 2 or 3 minutes. You can ask your question.
Okay, thank you very much. I equally want to appreciate Mr. Bumi for that apt lecture. I want to ask machine learning and artificial intelligence, what's the difference? Can we actually use both terms? Do they actually mean the same?
Okay, so we will get back to question and answer. I want us to attempt the self-assessment quiz I sent to the chat. And by 6 o'clock, we'll be allowed to ask questions and it will be available to answer. All right, thank you. Okay, it's 6 o'clock. So, Mr. Bumi, all right, so some questions have been posted to the chat room. So I'll read them while you answer them. Okay, so, so before I read the first question, somebody asked earlier what the difference is between machine learning and artificial intelligence. And more specifically, can these two terms be used interchangeably?
So the answer to that is no. They can't be used interchangeably. Though you find out in the industry, a lot of people try to do that, but the answer is no. And now I'm going to explain it in simple terms, right? I consider artificial intelligence as the mother, right? And then, well, let's put it this way. Artificial intelligence is more like the adult, and then machine learning is the growing baby that eventually becomes an adult. So, simple terms, artificial intelligence is going to help you to say, you're going to build, with artificial intelligence, your aim is to build or create intelligent systems that simulate human needs, right? You're looking at building intelligent systems that simulate human intelligence. But machine learning is just a subfield of artificial intelligence. In machine learning, you're using data to learn from past experience and then predict future experience. It is just a subset of artificial intelligence. There are a whole lot of other things that makes up artificial intelligence. This is where you start coming up with the deep learning and all of that, right? Artificial intelligence, the general goal of AI is to make smart computers that will help humans solve lots of complex problems, not just problems on data sets that they are given to. AI looks to solving a whole lot of complex problems that a human being cannot partake in. AI looks to performing tasks just like human beings, right? Like a human being now, you can't say a human being would only answer questions based on the data you are feeding him. No, a human being will answer questions as long as he's open to much knowledge that he's giving himself to. That is the essence of AI. AI is looking to build very large systems that would imitate human intelligence and simulate better human behavior. AI is a wider scope, but machine learning is just automatically learning from data provided. Machine learning is automatically performing tasks given to it from data sets in order to give accurate results and accurate predictions, accurate output. So machine learning is just a limited scope. It is answering based on the data given. While AI is a huge decision maker as regards anything at any point that a human being can do. So they are not the same. AI is more of a bigger term. An AI engineer should understand the concept of machine learning. But an ML engineer cannot call himself an AI engineer. Now, why do I say so? One of the things about artificial intelligence is the fact that you can be able to also build chatbots. But now, working with chatbots indulges you learning natural language processing. That's a part of ML. It doesn't just, it's not about giving data and predicting output. Artificial intelligence also includes computer vision, training models that will be able to see and detect objects. Now, this is not just the simple unsupervised linear regression that we're doing here. So can you see that AI is a bigger scope, while ML are just subsets that make this big scope? That is just the main difference between both. So the next question.
Thank you very much for that question. I hope that answers your question to the questioner. All right. So the next question.
Yes, thank you.
All right. Although we have 10 minutes to the end of this session, so we'll try to round up in that time. Yeah. So
all right.
I'm trying to get the second question. All right. So the second question is asking is quite similar to the first. What's the difference between ML and deep learning. ML as in machine learning and deep learning.
So I'm going to simply say deep learning is considered as the evolution of machine learning. Right? Simple. Evolving machine learning. That is what deep learning is about. Machine learning is simply your programming or you're giving out results based on data sets and all that. Whereas deep learning goes more. It goes further. It requires neural networks. It requires being able to explicitly build machines that will develop deeper things. I gave the example of computer vision. All of these are deep learning models. Neural networks are responsible for these things, right? So deep learning is simply evolution of deep learning. So let's say you started learning while we went to school. The first things we started learning was ABCD, right? That's the first thing you started learning from school. Now, while growing up in class, you started using that ABCD to make sentences, to write stories, to write paragraphs. That's just the simple difference between ML and deep learning. ML is the baby. Deep learning is evolved machine learning. Deeper models that are much more beyond feeding data sets and bringing out results. Models that are deeper in terms of understanding your tasks, models that are deeper in terms of accuracy, models with higher neural networks working for them. I think that's just the basic difference. Deep learning is evolving machine learning. That's all.
Thank you very much. And to add a little thing to that. So you made mention of neural network. So when these neural networks are so connected that it goes really deep, like the connection gets really deep. So think of it like a network, yeah, but nesting it on each other and making it to go really deep. And that is just deep learning. So thank you for the wonderful answer. Okay, there are no other questions here. Okay, are there different types or examples of reinforcement learning? That's the next question.
So for reinforcement learning, as regards examples, I gave a simple example, which is games. There are certain games now, even there's a popular chess game where you're going to be playing against the computer, the chess computer, and it starts to learn from your moves. It learns from your move as an agent, and then based on your moves, over time, it's been able to clearly specify, it's been able to clearly determine your moves, and then you can't, at that point, you won't be able to beat it again. So that's one example of reinforcement learning. However, for types, there are various types. I think from the top of my head, I know of two kinds of reinforcement learning. That's the positive and the negative reinforcement learning, right? The positive is simply saying an event is occurring based on specific behavior, right? And increases the strength and the frequency of that behavior. While negative reinforcement learning is a negative condition which the system has been able to clearly differentiate from. So basically there are two types, the positive and the negative. You can probably go online and read more about them and see the clear differences. Those are the two types of reinforcement learning I'm familiar with.
Thank you very much for the answer. So there doesn't seem to be any other question in the chat. I'll still leave if you perhaps want to read out your question instead, you can do so within the next 1 minute before we'll present. So we can see, like you rightly suggested, you can as well go online and just type types of reinforcement learning. So that's why I actually did this. So if you are not quite sure or you still want further explanation, it's not so clear to you, so you can go online and just Google types of reinforcement learning. You get a lot of answers. But what I can assure you is that the types are not limited. just as even the types of unsupervised learning are not limited, the types of supervised learning are not limited. So there are actually so many of them. So we can only introduce some of them to you. So it's your responsibility to go and make further findings to get deeper understanding. So is there any other question? If there is none, we'll just quickly review the answers here and make corrections before we call it a day. So if you have a question, you can indicate by maybe just picking up or just typing your question in. So, okay, so the first question we have from the quiz is, in order to group the customers of your business based on their characteristics, which category of algorithm will you use? So, and we have 4 options: logistic regression, decision tree, linear regression, and unsupervised learning. So I think just one person got that correctly. So the correct answer is linear regression, as he rightly explained during the class. So that with linear regression, you can estimate a fixed, like a continuous output. So price, for instance, is continuous. It's not fixed. It's not like having a fixed number of categories. So you can have today a price of, say, 50 naira, tomorrow a price of 100 naira, next or the day after a price of 200. So it's limitless.
I think that question is to a different answer.
Say again, please.
I think that question is to a different answer. The one you're answering now is for number 2. You are told to predict price of dollar to naira in the month of November.
Okay, that's true. That's true. Okay, thank you. Thank you. So this is the, in order to group customers of your business based on their characteristics, which category of algorithm will you use? Which category of algorithm will you use? Okay, so we have the answer there. Unsupervised learning is the right algorithm to use. So based on their characteristics. So let me actually take it from the top. So from the top, this is it. You are told to create a model that predicts the price of dollar to naira in the month of November. Which class of algorithm will you use? So that's linear regression, because you are predicting a fixed value is what you're predicting. So the next question is, in order to group the customers of your business based on characteristics, which category of algorithm will you use? And that is unsupervised learning algorithm. So the next is list any 2 types of supervised learning algorithm. And we have a wonderful list here: regression, k-nearest neighbor, naive Bayes, decision tree, linear regression, k-nearest neighbor. Yeah, so all these are correct answers. So list any 2 types of unsupervised learning algorithms. So k-means clustering, hierarchical clustering, and dimensionality reduction. Yeah, so that's also correct. And principal component analysis as well. So, and the next question is, which of the following algorithms is suitable to train a machine to interact with its environment without prior data? So that's what we discussed towards the end of this class. And the right answer is reinforcement learning. So that brings us to the end of this class. Mr. Bumi.